Hello everyone. This is Abhinaya, Assistant Professor from Hindustan Institute of Technology. Today we are going to see about machine learning, the definition and its types. The outcomes of this video is that you will be able to define and explain what is machine learning. You will be able to differentiate the different types of machine learning problems that are available in the real-time world. You will be able to use machine learning to predict the outcomes based on the input variables in real-world datasets. You will be able to analyze the suitable algorithms for the real-world problem. So what is machine learning? Machine learning is a subset of artificial intelligence. Artificial intelligence is an area of computer science where we are providing intelligence to the computers to think like a human. Machine learning is creating an algorithms or statistical models that will help your system to get the intelligence. So this machine learning will make your computers to identify the hidden patterns from the data and make predictions based on the patterns. So there are three different types of machine learning. Supervised machine learning uses labeled training set. So I'll be telling you what is labeled training set in the upcoming slides. Unsupervised learning uses unlabeled training set. Reinforcement learning works on the feedback process. That is, it is the main example of this reinforcement learning is robots. So robots learn by their feedback. That is based on the feedback that is received, whether it is a reward or a punishment. If it gains a reward, it will identify that the process, that is the task that it is taking, is correct. If it gets a punishment, it will identify that the task that has performed is wrong. So this is a comparison for your labeled and unlabeled data set. So this is a labeled data set. So supervised machine learning algorithm uses labeled data set. So what happens here is my training data set is a set of dog and elephant images. So I am going to create a model. So this model has to tell me whether it is a dog or elephant. So my training data will have a set of images like this, and each images will be given a label about their name of that animal. So if I take this image, this images will be given a label that it is an elephant. So this image will be given a label that it is a dog. So initially we are providing the images of the animals with their labels to the model, so that the model will identify that each image will belong to any one of this category. So this is a unsupervised model. So unsupervised model will have unlabeled data set. That is, I have only the set of images. I don't have the names of those images. So I will not be providing the labels with these images. I just provide the images to the model. I am not providing the labels. So supervised machine learning uses labeled data set. That is, it has the images will be given a name whether it is an elephant or dog. But unsupervised machine learning is an unlabeled data set that it does not uses a label. It is given only with images. So this is a sample data set. So the input that you are providing to your machine learning model of supervised data set is something this. So you have set of images like this, and each images is provided with a label. So I will say that this is an image of a dog, this is an image of an elephant, this is an image of an elephant. Like that I'll be providing label to all the images that I'm going to give it to the model for training. So these are all the inputs for unsupervised machine learning, where I have only the images, I don't have the labels along with them. So this is the working process of machine learning model. So what happens is, this is for unsupervised machine learning. So I have a training data set like this. So a model need two sets of data, that is training data and test data. So what is training data is? Training data is a set of past experiences that is given to the model to identify the patterns that is provided inside them. Test data is nothing but these are the data that is given to the model to make the predictions on what it is learned through your training data. So here I have a set of training data. These are all my set of training data. So since it is a supervised learning, I have set of images along with its labels. So I am giving this to my system. Along with this, I am going to feed any one of my machine learning algorithm. So this algorithm will identify the patterns that is present in these images. So what kind of pattern is available for elephant? For example, it will try to identify that elephant has a long trunk like this. So it will try to identify the patterns that is present in the images. Then these are all my test data. So when I give a set of images like this, whether if I give a set image of a dog or if I give an image of an elephant to my model that is created from my training data, then that model will predict me whether that image is a dog or elephant. So this is an unsupervised learning model. So here I am not giving my labels. So my training data set consists of only images. It does not have a label. So I am giving set of images to my computer with my machine learning algorithm. So I am giving test data to the model that is created through my training data. So this is the output that I receive. So the output will be, it will group your images based on the similarities. So since I don't have any labels, I don't know the name of these animals, but I try to identify that these animals are similar in the images and these animals are similar. I will group them based on the similarities. I'll try to say that this group is a cluster 1 and this group is a cluster 2. I don't have the name of those animals when I'm training my data. So I just say these set of animals belong to a same group, that is cluster 1, and this set of animals belong to a same group, that is cluster 2. So what is the difference between your supervised learning and unsupervised learning? So the supervised learning, as I said, it uses your labeled training data set. Unsupervised learning uses your unlabeled training data set. So the supervised learning is further classified into two types, that is classification and regression. So classification is nothing but my output variable is a categorical variable. So output variable is nothing but it is a label here. So label is categorical. So what is categorical? It is a set of discrete values. It is set of categories. So in my example training data set, I had two categories, dog and elephant. So it can be categories like true or false, yes or no, 1 or 0, positive or negative. It can be any different categories that is present in your training data. So this classification algorithms will have labels that is categorical. So the algorithms that are involved in classification is support vector machines, logistic regression, decision trees, or the different algorithms that are involved in classification problem. So what is regression is, I have a label that is a continuous number. Instead of category, I have a continuous number. So what is continuous number? So I try to predict the price of a house. So for example, based on the area of the house, whether it is 2000 square feet area, whether it is 1000 square feet area, whether it is available in the rural area or whether it is available in the urban side, and based on the number of bedrooms, whether it is 2 BHK, whether it is 3 BHK, based on all these data, I will try to identify the price of the house. So the price of the house is a continuous number and it is not a category. We cannot categorize the price. Same way, if I am trying to predict the weather of today, so I try to predict that tomorrow will be you will be having a temperature of around 37 degree, or tomorrow you will have a temperature of around 38 degree. All these are my continuous numbers. So if I try to predict whether it is hot or cold, whether if I'm trying to predict tomorrow's weather will be hot or if tomorrow's weather will be cold, then it becomes a classification problem because I have only two categories, that is hot or cold. But if I try to predict it as a temperature, that is if I try to predict it as 35 degrees Celsius or 37 degrees Celsius, then I call that it is a regression problem because it is a continuous number. So some of the algorithms that we can use for regression is simple linear regression and multiple regression. So for unsupervised learning, there are two main categories, that is clustering and association. So clustering is nothing but grouping your objects into different clusters. I am grouping my objects into different clusters based on the similarities. Then I call that it as a clustering. So I don't have a label here. It is an unlabeled data set. So I will be grouping them based on the similarity of their data points. So the example for your clustering algorithm is k-means clustering. Then next category is association. So association is nothing but I'm identifying the dependency of various data items and maps the associated variables. And here I'm going to identify what kind of dependency available between different variables. So for example, if I go to a supermarket, I'll try to I can see that all my stationery things are placed on the same side. All my uh, snacks items or all my pulses, like that, they will be categorizing the different variables and they will be placing it on the same place. Why they are placing it like that is, so if I try to buy a notebook, if I go and buy a notebook, when I see a pen that is placed near my notebook, so by default I try to buy two pen also. So they are identifying the relationship between the pen and notebooks. So based on the previous purchases that is done by the customers, so most of them would have bought pen and notebook together. Most of them would have bought bread and jam together. So those kind of relationship or dependency between the variables will be measured using association. So this is called a dependency between the variables, and we are placing them together in order to improve our profit or in order to improve our sales. So this dependency can be measured using a priori algorithms. So this is what is all about your introduction. So let us check our knowledge. So the first question is, which statement is true about machine learning types? So you can see the different possibilities and try to identify the answer. So the answer is, supervised learning is a machine learning approach that uses labeled data to train the models to make predictions. So the second question is, in what scenarios is unsupervised learning most beneficial? So you can go through the options. So it is beneficial for clustering and association tasks. What are the main types of supervised learning algorithms? So the supervised learning algorithms include classification and regression. Then what is the purpose of unsupervised learning? It is used to group your similar data points without labeled outcomes. So what is the significance of training set in machine learning? So it is used to train your model by providing it with examples to learn from. So machine learning is a subset of what? It is a subset of artificial intelligence, which is the innermost part of this given image. So machine learning is a subset of artificial intelligence, and deep learning becomes the subset of machine learning. Dash is a type of problem that is handled by supervised machine learning. So supervised machine learning handles both classification and regression type of algorithms. So Dash is a feedback-based learning method. It is reinforcement learning. So observe an image and identify the type of machine learning. So here we have a training data set. So this data set doesn't have any labels. This raw data is passed through the algorithm and it is grouped into different groups, that is clusters. So this image belongs to unsupervised machine learning. So that's it. So now let us move on to the applications. So machine learning involves various applications. It is being applied in majority of the places. So the first application that we see in our day-to-day life is automatic friend suggestion. So this friend suggestion we usually get it in social media networks. So most of you might have familiar with the friend suggestions that we receive and auto tagging of photos that happens in your social media networks. So that is because of machine learning. And the second application is traffic prediction. Most of us use Google Maps when we travel along the routes. So this machine learning algorithms will predict the traffic through the route that we are traveling. Then speech recognition. So most of us do voice search in Google, so which is one of the applications of machine learning. So then spam email filtering. So all of our mails has a different category called spam. So most of our the mails that we receive will be categorized and it will be stored as either spam or not spam. So it is done by an AI model. Then the last application is virtual assistants. So we have so much of virtual assistants like Siri, Alexa, Google Assistant and everything. which we regularly use in our day-to-day life. So these are all just common examples that we use in day-to-day life. So it is not restricted to, the applications are not restricted with this. There are a few more applications, that is implementing machine learning and AI models. So for the sake of few, I have given a common applications that we use regularly. But there are lots and lots of applications that we regularly use in our smartphones, regularly we use in our laptops, and everywhere we see. So we get product recommendations through YouTube's, we get product recommendations from online shopping marts. Everything is an AI model. So I hope you all got a introduction about a knowledge on machine learning, its types of problems that are available in machine learning, and the places where you can see this machine learning is applied. So thank you.